Welcome back, everyone. We are finishing up topic 18. We are solving quadratic equations. This is student activity sheet 3, and we're going to talk about how to solve quadratics using the square root method and by factoring, something you know how to do already. So in the previous lesson, we talked about how to find solutions through a graph, and today we're going to talk about how to do them other ways. So the first thing I want to talk about is what happens when we take the square root of a number. And what we talk about with square roots. Square roots, if I asked you what the square root of 4 is, you'd tell me 2. If I asked you what the square root of 3 is, you would tell me 9. I'm sorry, if I asked you what the square root of 9 was, you would tell me 3. If I asked you square root of 16, you would tell me 4, and so on and so forth. But let's talk about what it means to actually take the square root of a number, okay? So in this example, we have 3, the number 3 and the number 9. 3 is a square root of 9. That means we can take two identical factors, 3 and 3, and put them together to get the number 9. So an example with the number 16, it's made up of 4 and 4, okay? So let's look a little bit more about that. The principal square root of 9 is 3. Okay, that's the one that everyone immediately thinks of. However, with this, we have some other things that we need to keep in mind. So a couple things that I want to take note of before we get into this. What the heck is a square root? Our square roots are made up of our radical sign. Okay, so this is our radical. And then what is inside the radical is called the radicand. Okay, so important things to know there and keep in mind going forward. So with this now, when they ask you what is the negative square root of 9, when we talk about the negative square root of 9, that is if we take this negative sign and put it in front. Well, what is the square root of 9? It's 3. And when we take the negative of that, that means it's going to be negative 3. Okay? And how we can check this, if we go the other way, negative 3 squared means negative 3 times negative 3, and that's also 9. Okay, so what we need to understand from that is that for every single square root, there are going to be two numbers that it could equal. So if I asked you guys for the square root of 16, that could be 4 or negative 4. Okay. So now we're going to go on to these questions. On question 2 here, what they're asking us to do is solve these. Well, how the heck do I solve this? Well, just like we did with our other equations, if I want to know how to get rid of a plus, we did the inverse operation, which was to subtract. If we wanted to get rid of multiplication, we would perform the inverse operation, which means to divide. So when we're looking at our squared terms, the inverse operation of a squared term is to take the square root of it. So with this, if I take the square root of x squared, that means I also have to do it on this side. So I'm taking the square root of 9 also. Now again, remember, those roots can produce both a positive and a negative answer for us. So with that, I could say that x could equal 9. The square root of 9 can equal either a positive 3 or a negative 3. Okay, and if we check that back with our answers, we'd find 3 squared equals 9, and then negative 3 squared is 9. Same thing with the x squared equals 16. Square root, both sides to get rid of that squared term, and it produces both a positive 4 and a negative 4. So now let's take a look at when we do these answers here. Down in equation 3 and equation 4. With that, when I take the square root of both of those sides, it doesn't matter so much that there's other things now, okay? So we still take the square root of it, But remember, we just said the square root of 9 produces both a positive and a negative 3. So we're going to show that x plus 1 equals 3, or x plus 1 can equal a negative 3. Over here, x plus 2 can equal a positive 4, or it can equal a negative 4. And go through and solve these just like we'd solve a regular equation. Subtract 1 on both sides, and we get that x can equal a positive 2. And if I did over here, a negative 4. Over here, when we subtract 2 on both sides, it gives me an answer of positive 2 or negative 6. Going on, is it possible to solve this equation using square roots? And the answer is no, it's not, because we cannot model that on the left-hand side. These are not perfect squared numbers. Okay, go ahead and cross off number 7. We're going to go on to question number 8. Okay, if we take a look at question number 8, this is the problem that we just said that we cannot take the square root. So we're going to have to solve it a different way. So the first thing that they ask us to do is to rewrite this in factored form. Okay, and I've gone ahead and I've already factored this for us. And I got x plus 2 and x plus 3. This is something you guys already know how to do. This was our diamond problem. Okay. Now, the important thing to remember here is that when we go to solve these, we need to use the zero property rule, in which case in order for this to equal 0, at least one of the factors has to equal 0. Remember, because anything times 0 is 0. So in order for this to be a 0, that means one of these or both has to equal 0. Okay, so what we're going to go ahead and do here is we are going to solve the equation by splitting these factors apart. We're going to take that first factor and write it as x plus 2 equals 0. And then we're going to take this second factor and write it as x plus 3 equals 0. And then we're going to solve each of those to get x equals negative 2 or x can equal negative 3. Okay. Okay. Again, this is called the zero product property. And that is that in order to get a 0 through multiplication, one of the numbers has to be equal to 0. So let's take a look at question 11 here. What is the first thing that we must do in order to solve this by factoring? The first thing is that this has to equal 0. Okay, these equations every time, guys, has to be set equal to 0. Therefore, in order to make this equal 0, we have to get rid of this 36. How do I move a positive 36? I'm going to subtract it on both sides. Okay, so let's go ahead and take a look at number 12. Okay, we're going to go ahead and factor and solve this equation out. Before we can do that, again, we need to, step 1, set it equal to 0. So with that, I'm going to subtract my 36 on both sides. And when I do that, I'm going to get 2x squared minus 3x. And then 16 minus 36 is going to be negative 20. And this now equals 0. Okay, so now step 2 is going to be to factor. Okay, I'm going to go ahead and make my x here. Okay, 2 times negative 20 is negative 40. Drop down my inside. My two numbers that can multiply to make a negative 40, but add to negative 3, that's going to be negative 8 and positive 5. Don't forget to divide by a. Divide by a on both sides. That one is simplified. Negative 8 divided by 2 does simplify down to negative 4. So my two factors here are going to be x minus 4 and bottoms up 2x plus 5 equals 0. Okay. And if you want to see that a little bit bigger, I do have that down here for you to see. Next thing that we're going to go ahead and do here is we're going to set each factor equal to 0. And you can see I did that down here. I don't want to rewrite that again for you. Okay, so again, I set each factor equal to 0. And then step 4 is to simply solve. So I'm going to add 4 to both sides, and I get that x equals 4. Over here, I have to subtract 5 on both sides, and I get that 2x equals negative 5. And then divide both sides by 2, and I get that x equals negative 5 over 2. Okay. Question 13. Okay, question 13. Again, they want us to just go through and solve each one of these by factoring. So you can see on these first two problems, very first step, guys, is I make it equal 0. So you can see I rewrote both of these. Okay, you can go ahead and check that factoring out. Set each factor equal to 0 and solve. You get x equals -6 and x equals 5. Come over here. Now you'll notice on this one, I had to divide by 4 to start. Get a greatest common factor. You can stick it out front. It's not going to change the problem. You don't have to worry about it anymore. You get your factors and you solve like normal. Same thing here on parts C and D. Okay, you end up getting x equals -5 and x equals 1/2. Go ahead and pause the video here, guys. You can go through, write these things down, take note of what's happening, even try to do them on your own. Okay, so now let's take a look at a little bit of a more challenging equation here. Okay, they want to know what is going to be the first step in factoring this. Well, first of all, let's just focus on this, and that is going to be to factor out a greatest common factor. Okay, so when I look at this, my greatest common factor between the two is going to be -16 and t. Both of those numbers go into both terms. Okay, I'm going to rewrite it as a product. So this is simply stating -16t times t minus 4. Again, I have it written here. So let's use my two factors. Okay, we can't factor that any further. So we're going to split it. -16t equals 0, and then t minus 4 equals 0. And then when I ask you what are the roots, okay, we've talked about the roots before. Roots are my zeros, my intercepts, okay, my solutions. This is also the same thing here, the same thing that we've been finding on these other problems. So what are they? It's t equals 0 and t equals 4. Okay, how did I get that? Okay, you can solve each one of these. Divide both sides by -16, and I got that t equals 0. Here, add 4 to both sides, and we get that t equals +4. Okay, and again, this matches that balloon height and time problem that we saw. Okay, what does it mean? 0 and 4 are the roots. The balloon will be at the ground, 0 feet high, at both 0 seconds and 4 seconds, at takeoff and landing. Okay, so in this next one, how can factoring help you find the axis of symmetry of the parabola and the extreme solution? The big thing to understand here, guys, is that axis, let's talk about some of these terms. Your axis of symmetry, a parabola, you can notice it by the graph here. A parabola is symmetric on both sides, meaning what happens on one side happens on the other. Okay, we also know that what goes up must come down. So your axis of symmetry runs right through the middle of a parabola. Okay, and so with that, your axis of symmetry, because it goes through the middle, it's going to be in the middle of your 2x intercepts. So our 2x intercepts were at 0 and 4, which means the middle was 2. Okay, that means my axis of symmetry lies at 2. The vertex, that is the maximum height or the lowest. It's either the highest point or the lowest point, depending on which way it opens. Okay, that runs right through the middle. Okay, that's also called our extreme. And here it's at 2 seconds. Okay, so we know our axis of symmetry was at 2 seconds. So if I fall over to 2 seconds and go up, where is that at? It's at roughly 64, meaning the water balloon reached its highest point at 64 feet, which was 2 seconds after its launch. Okay, real quick, we just want to go through and take note, what's our perfect square? So that means like your 4, your 16, your 9, okay? Some things to know here, guys. 4x squared, that is a perfect square, okay? 4 is a perfect square, x squared is a perfect square. Now, my x squared plus 1, that is not a perfect square, okay? Not a perfect square because of this middle section. my x plus 1 and then squared? Yes, because the whole thing is squared. Okay, 4x squared plus 4x, no, because of that middle term, it is not a perfect square. Now, x squared plus 4x plus 4, yes, that is a perfect square. X squared plus 6x plus 4, no. X squared plus 6x plus 9, yes. And x squared plus 10x plus 25, yes. Now, you guys can go through and you can take note how I showed you what the perfect square is from. If you're unsure, you can always go back and factor those. Okay, so something I want to take note of down here at number 20. Okay, we don't have to just factor to get our solutions. We can solve by taking square roots, because I recognize, because we just said it right here, that this is a perfect square. I also note that the number 9 is a perfect square. So how can I rewrite that? If I factored that, it would look like this. My 9 stays a 9. Well, I can square root this side and square root this side, in which I get x plus 5 equals 3 and x plus 5 equals negative 3. Solve for that, and I get that x equals negative 2 or negative 8. Now you could do it the way, just plain factoring, set it equal to 0, factor it, solve it. So you can do that 2 separate ways. Okay, let's take a look at a couple other things here. Can I do this on number 21? No, this is not a perfect square. 5 is not a perfect square. We cannot solve it by just taking square roots. We must set it equal to 0 and factor it. So here, I went through it real quick. Okay, factored it for you so you can see it and got my solutions. Now these ones down here, let's solve them by both factoring and by square roots. Let's start by just solve by factoring. Okay, make sure they equal 0. I went through and factored both of them, and I got that x equals negative 6 and positive 6. Come over here, I factor it, and if I pull that common factor out, it leaves me with x squared minus 25. Okay, and I can go through and again factor it, and I get my 2 answers. Now, I can also solve this one by taking square roots. Okay, when I go through on this, I happen to see that 36 is a perfect square. Can I add that to the other side? Yes, I get x squared equals positive 36. Now I can take the square root of both sides, and I remember take both the positive and the negative, and I get 6 and negative 6. That matches what I have up here. Same thing here. When I'm going to go ahead and add my 50 to the other side, divide by 2, and I get that x squared equals 25. Again, 25 is a perfect square, guys. So I'm going to go ahead and take the square root of that. Again, both a positive and a negative, and I get 5 and negative 5. With this, guys, if you are confused about this way, we know how to factor. This is your surefire plan. This will work every single time. If you're not sure if or when this is going to work, don't worry about using it. Okay, your teacher will go through more of this with you. You got a bunch of reinforced questions that you can work through. And I'll see you back here tomorrow for your next video. Bye.